Hey math students, this is Dr. Sweeney. What we're going to be looking at today is we're going to be looking at Boolean functions. And so what a Boolean function is it's a way of taking from a set Bn into B. And remember, Bn is like a Cartesian product. It's an n by n set where we just have those Boolean values 0 and 1. And what we're going to do is we're going to see how it is that we construct these functions, because later on we're going to go out and actually simplify the functions or actually transform them in order to tell us even more about Boolean algebras. We need to start out with a couple of definitions. The first definition that we need is we need the definition of a Boolean variable. So a Boolean variable, it can take either the value 0 or 1. We represent them with letters, x's, y's. We saw them in a previous video, so you can kind of get that sense. A literal then is either the variable x or its complement x bar. So we actually expand the idea of a variable and we expand it to either x or its complement x bar. Right? And that allows us to either have 0 or 1, depending upon what value that we choose for x. And then a minterm is a product of literals. For example, we might have x, y bar, z bar, or x, y, z bar, or any kind of product of any literals. And that's what we call a minterm. Now let's define the Boolean function. And what a Boolean function will do is it's going to map from the set Bn into B. And remember that B is equal to 0, 1. For example, the function f, which goes from B3 into B, it might map, say, f of 0, 1, 0. So I'll take 3 Boolean values, and it'll map it onto a single value, in this case, 0. And what we might have is we might have a function f, and it might have this functional table. And the functional table, what you'll see here is I've taken all the possible values for x, y, and z, okay? And I put them inside of a table, and then I've given the value for that function. So what you can imagine is that this is the entirety of the mapping for x, y, and z onto f of x, y, z. And just notice that there are 8 rows in the table corresponding to the 8 different combinations of 0 and 1 in B3. Okay? And so, for example, we have 0, 0, 0, that's going to map into 1. 0, 0, 1 will also map into 1. But 0, 1, 0 will map to 0. And so what we do is we actually generate the entirety of all of the values that we get from the possible values of 0 and 1 in B3 onto whatever values we have for f. What we're going to look at now is we're actually going to look at how is it that we generate the actual term. So now what we want to do is we're going to generate the functional expression from the functional table. And so we have to remember a couple of things about operations in Boolean. So 0 times 0 is going to equal 0. 0 times 1 will equal 0. 1 times 0 is going to equal 0. So anytime I multiply anything times 0, I get 0. And only when I multiply 1 times 1 am I going to get 1. And that actually goes for any string of variables. We have to have all 1s, all right, in order to get 1. If we have any 0s, we're going to end up having 0. In addition to that, if I take 0 plus 0, I get 0. But 0 plus 1 equals 1. 1 plus 0 is going to equal 1, and 1 plus 1 also equals 1. So when I add, if I add 1 to anything, I'm going to get 1. And in fact, right, if I took 1 plus 1 plus 1, that would be 1 plus 1, that's 1. Plus 1, that's another, that's just 1 again. So it doesn't matter how many strings of 1s that I have. For example, if I have 1 plus 1 plus 1, right, that's going to be 1 plus 1, and that ends up equaling 1. So it doesn't really matter how many strings of 1s that I'm adding together, I'm just going to still end up with 1. Doesn't matter how many literals that I'm multiplying together, if I have a single 0, I'm going to end up with 0. So given that that's the case, what we can do is we can actually generate a function from the table. So I'm going to look at, and I'm going to point to each value inside of my table where the function equals 1. Right? In this case, for this table, I've got 3 1s. Okay? And so what I'm going to do is everywhere where I have a 0, I'm going to take the complement, and that's going to be my literal. And so in this case, I've got x, y, and z are all 0s. X bar, y bar, z bar. So when I multiply the 3 of those together, I get 1. Okay? Because 0, 0, 0, it's going to give me 1. For my second row, I'm going to notice that x is 0, y is 0, but z is not. So I'm going to have x bar, y bar, z bar. And that's going to be my second minterm. And then my third minterm is going to have x, and then we'll have y bar and z bar. And so those are going to be my 3 minterms, the 3 minterms that I'm going to need for my expression. I'm going to take those three minterms and I'm going to add them all together. X bar, Y bar, Z bar, plus X bar, Y bar, Z, plus X, Y bar, Z bar. And that's going to end up equaling my function. So that's f of x, y, z will equal those three. And if you think about it, it makes sense, because what ends up happening is that if I have any of these combinations, say for example I have 0, 0, 0, this becomes a 1, but then everything else becomes a 0, right? Because z is 0, that becomes 0, and x is 0, so that also gives me 0, so I'm adding 1 plus 0 plus 0. But even if there were 1s, it wouldn't even matter, okay? Because it would still be 1 plus 1 plus 1. Not a problem there either, okay? Now, let's say, for example, I take one of these ones where we have a 0. So let's take a look at this one here, that sixth line. So if I take f of 1, 0, 1, that's going to end up being the complement of 1. So that's 0. The complement of 0, that's 1. The complement of 0, or 1, that's 0. Plus, and then second term, we're going to get 0, 0, 1, 1, plus, and then the third term is going to be 1, 1, and then 0. So if we look here, this is going to be 0, first term, plus 0, plus 0, and we add the three of those together, we're going to get 0. And you can go in and you can actually check for any value inside of that table, right? You'll just go in, evaluate each one of the minterms individually, add them all together, and you'll see that if it's in one of those lines where we had a 1, it'll be 1, and if it's in one of those lines where we had a 0, it's going to become a 0. Let's take a look at another example. So in the second example, it's actually simpler. It's only a function of two variables, so this is going to go from f, and it's going to be from b2 into b. And now what we're going to do is we're going to identify each place where we have a 1. So that's line 1, line 1, line 2, and line 4. And so what we'll get here is we're going to have x bar, y bar, all right? So anywhere we have a 0, we're going to actually take the complement to make it into a 1. Second line, we're going to get x bar y. And third line, we're going to get just x and y. And that gives us one for each line. Then we'll just add the three minterms together, x bar y bar plus x bar y plus xy, and that is our function f of x, y. You can go in and check your table, and you'll see that in fact what we get is we get a 1 if we're in any of those rows where we have a 1 and a 0 anywhere else. Just to review, a literal is either a variable or its complement. A minterm is a product of literals. A function in this section is going to be a sum of minterms. So to construct a function from a table or a set of values, you want to generate a minterm from each row in the table that is equal to 1 using literals, and then add each of these minterms together to form the function. And that's our basic introduction to Boolean functions. This is Dr. George Sweeney, and I want to thank you for watching my video. If you found it helpful and you liked it, go ahead and click the thumbs up. If you want more of these videos and you want to get my updates, please click subscribe. If you have any questions or you just want to say how much you really enjoyed the video, go ahead and leave some comments. I do read and respond to the comments.